Welcome to Raw History. Here, we cut through romanticization and speculation to show you, well, the unfiltered reality of human history. When American GIs landed on the beaches of North Africa in November 1942, they carried with them a piece of equipment that would earn legendary status among the troops. The Coleman M-1941 pocket stove, designated as Model 520 by its manufacturer, represented one of the most successful pieces of military equipment developed during the entire war. War correspondent Ernie Pyle, who spent years embedded with American forces, famously ranked it just behind the Jeep in terms of usefulness to soldiers. This wasn't hyperbole. In the brutal realities of combat across 3 continents, this compact stove became an absolute necessity for survival. The development story itself reveals how military innovation happens under pressure. In early 1942, the U.S. government presented the Coleman Company of Wichita, Kansas, with seemingly impossible specifications. They needed a stove that weighed no more than 3 pounds, stood no taller than a quart-sized thermos bottle, could burn any available fuel from gasoline to diesel, and had to operate reliably in temperatures ranging from negative 60 degrees Fahrenheit to positive 125 degrees. The kicker? Coleman had just 60 days to design and produce a working prototype. The engineers at Coleman succeeded beyond anyone's expectations, creating a pressurized burner system that would go on to influence portable stove design for decades. The first 5,000 M-1941 stoves accompanied American forces during Operation Torch, the invasion of North Africa. By war's end, over 1 million units had been manufactured by Coleman and the American Gas Machine Company of Albert Lea, Minnesota. The stove featured a brass or steel fuel tank, depending on the manufacturing year, a hand-operated pressure pump, and a highly efficient burner head that could bring water to boil even in howling winds. Soldiers quickly discovered that the stove's compact design meant it could fit in a coat pocket or vehicle glove compartment, making it, honestly, infinitely more practical than larger field kitchens that required transport and setup time. While American forces relied on engineered solutions, British and Commonwealth troops in North Africa developed their own heating innovation out of pure necessity. The standard cooker, portable No. 2, issued to British armoured vehicle crews, proved virtually useless in desert conditions, constantly clogging with sand that infiltrated every mechanical component. What emerged from this frustration became known as the Benghazi burner, named after the Libyan port city that served as a critical Allied logistics hub after its capture in February 1941 during Operation Compass and subsequent recapture in December 1941 during Operation Crusader. The construction was brilliantly simple. Soldiers took empty 4-gallon steel fuel cans, nicknamed flimsies due to their thin construction and tendency to leak, and cut them in half. They pierced holes around the upper portion to allow oxygen flow, then filled the bottom half with desert sand. Petrol would be poured onto the sand and stirred to create saturation, then ignited. A second flimsy could be placed on top as a cooking vessel. The design had multiple advantages. It was silent, fast, and the necessary materials, empty cans, sand, and fuel, were readily available throughout the desert theatre. The cultural significance of the Benghazi burner extended far beyond simple cooking. Tea became, well, almost a sacred ritual in the British Army during the North African campaign. One soldier recorded that morale was directly proportional to the supply of brews and described tea as having become like a drug to us. The numbers tell the story of this obsession. A single battalion could consume nearly 100 gallons of fuel per day just for making tea. Recognizing this critical morale factor, the British government took an unprecedented step in 1942. They purchased the entire world's available supply of tea on the European market to ensure their forces would never run short. The Benghazi burner had limitations. the petrol-soaked sand could explode when first ignited, creating dangerous flare-ups. The fuel also burned inconsistently, sometimes too quickly, sometimes sputtering out. Despite these drawbacks, British forces continued using Benghazi burners throughout the Italian campaign and even during the Northwest Europe campaign. The morning of December 16, 1944, brought temperatures of 14 degrees Fahrenheit to Bastogne, Belgium, but that was just the beginning. As Hitler's last major offensive smashed into thinly held American lines in the Ardennes forest, soldiers faced a double enemy, the Wehrmacht, and one of the harshest winters Europe had experienced in decades. Temperatures plunged to negative 20 degrees Celsius, approximately negative 4 degrees Fahrenheit, and soldiers who didn't die of hypothermia were crippled by frostbite and trench foot. The Battle of the Bulge lasted from December 16, 1944 to January 25, 1945, making it not only the deadliest battle for the US Army in terms of casualties, but also a brutal test of winter survival. American forces were catastrophically unprepared for winter warfare. The Ardennes had been considered a so-called honeymoon sector, a quiet stretch of the front where exhausted units could rest and new arrivals could, ease into combat. In December 1944, only 4 American divisions covered an 89-mile front. When the German offensive struck, many reinforcements were rushed to the front so hastily that they arrived without proper winter clothing. The standard leather-soled combat boots absorbed snowmelt, leading to epidemic levels of trench foot that required thousands of amputations. Standard-issue gloves proved inadequate. Web equipment froze solid overnight and had to be beaten against trees to make it pliable. And, weapons malfunctioned constantly in the cold. Desperation breeds innovation. Soldiers discovered they could warm their feet by holding them near burning heat ration tablets or waxed K-ration boxes, which, produced good flames with minimal smoke. Some stuffed straw inside their overshoes for insulation, while others wrapped their feet with strips of blankets or even newspaper. Company commanders observed that removing leggings actually helped keep feet warmer because wet, frozen leggings would tighten around legs and restrict blood flow to the feet. Soldiers also adapted their tactical approaches. Blankets became makeshift insulation, scarves were sewn from sandbags to protect faces from wind, and tree branches reinforced foxhole roofs against shrapnel and falling ice. When sea rations froze solid, men thawed them over open flames. When supplies ran out entirely, some boiled pine needles to extract vitamin C, while others scavenged frozen horse meat from fallen cavalry units. In one of the more desperate measures documented, soldiers discovered their machine gun bolts would freeze, preventing the weapons from firing. The improvised solution? Urinating on the bolts just before firing to provide enough warmth for the mechanisms to function. These heating solutions, from engineered marvels like the Coleman stove to improvised devices like the Benghazi burner, operated on fundamental principles of thermodynamics that, remain relevant today. The Coleman M-1941's pressurized fuel system created an atomized spray that burned with exceptional efficiency, converting liquid fuel to vapor before combustion for maximum heat output. The stove's compact burner head concentrated heat in a small area, allowing rapid boiling even when exposed to wind, which honestly normally carries heat away from cooking surfaces. The Benghazi burner worked on an entirely different principle. Sand acted as a wick, drawing petrol upward through capillary action, while simultaneously serving as a heat reservoir. As the petrol burned at the sand's surface, more fuel wicked upward to replace it, creating sustained combustion. The air holes pierced in the can's sides created a chimney effect, drawing oxygen into the combustion zone and carrying hot gases upward. This passive air circulation required no mechanical components, making the design virtually indestructible and maintenance-free in harsh desert conditions. The improvised heating methods used during the Battle of the Bulge demonstrated soldiers' intuitive grasp of heat transfer principles. Heat ration tablets contained hexamine, a chemical compound that produces approximately 7,500 BTUs per ounce when burned. Waxed K-ration boxes utilized the paraffin wax coating as fuel, which has a high energy density and burns cleanly. Both materials could, raise the temperature in a foxhole by several degrees, and that's often the difference between survivable conditions and hypothermia. Insulation methods like straw stuffing or newspaper wrapping worked by trapping air in small pockets. Air is actually an excellent insulator when it's stationary. The materials simply prevented convective heat loss that would otherwise sap body heat. The innovations born from World War II desperation, they continue influencing modern military and civilian equipment. The Coleman pocket stove's design principles directly informed post-war camping stove development, which led to the compact backpacking stoves used by millions of outdoor enthusiasts today. Military forces worldwide still issue compact liquid fuel stoves to troops, though the modern versions incorporate improved safety features and materials that just weren't available back in the 1940s. The Benghazi burner principle, which uses absorbent material to regulate fuel delivery, actually appears in contemporary survival stoves and emergency heating devices. Modern hobo stoves and various bushcraft heating methods employ the same sand and fuel approach discovered by British troops in the Libyan desert. Over time, the concept has been refined with better fuel choices. Ethanol gel often replaces petrol these days, and with improved container materials as well. But the fundamental physics remains unchanged. Perhaps most importantly, these stories remind us that effective solutions don't always require advanced technology or expensive materials. The M-1941 stove succeeded because Coleman's engineers understood the real constraints soldiers faced. Weight, reliability, and fuel flexibility mattered more than theoretical efficiency or manufacturing complexity. The Benghazi burner worked because it matched available resources to actual needs, prioritizing simplicity over sophistication. The improvisations at Bastogne saved lives because soldiers understood that any heat source, no matter how crude, was better than none. For modern preppers, survivalists, or anyone interested in emergency preparedness, these historical innovations offer practical lessons. Understanding that insulation works by trapping air, not by material thickness, changes how you approach staying warm. Recognizing that efficient combustion requires proper air-to-fuel ratios and heat concentration helps you build better emergency heating devices. Most crucially, these stories demonstrate that resourcefulness and adaptability often matter more than equipment. The soldiers who survived the Battle of the Bulge didn't have the best gear, they had the best mindset. If you found this deep dive into verified World War II heating innovations valuable, subscribe to Raw History. We're committed to cutting through speculation and bringing you evidence-based history drawn from primary sources, military records, and documented accounts. Share this video with fellow history enthusiasts who appreciate accuracy over sensationalism. The past has enough genuine drama without needing embellishment. We just need to dig deep enough to find the real stories that shaped our world.